Far from the Sun's protective embrace, the frontier of our solar system appears to be a cold, empty and dark place. For a long time, the yawning space between us and the nearest stars was supposed to be a terrifyingly enormous stretch of nothingness. It was a place that humanity could only observe from a distance until lately. It received scant attention from astronomers who preferred to direct their telescopes on the blazing masses of our nearby galaxies, stars and nebulae. However, two spacecraft built and launched in the 1970s have been beaming back our first sights of this weird zone we call interstellar space for the past few years. They are the first man-made objects to depart our solar system and are travelling billions of kilometres away from Earth. No other spacecraft has travelled that far. Stay with us until the end, as today we have something spooky and strange discovered in the vastness of space. When you look at different parts of the electromagnetic spectrum, that area of space is very different from the blackness we see with our eyes, says Michelle Bannister, an astronomer who studies the solar system's farthest reaches at the University of Canterbury in Christchurch, New Zealand. Magnetic fields are fighting, pushing, and becoming entangled with one another. Imagine yourself in the plunge pool beneath Niagara Falls. Instead of tumbling water, however, the turbulence is caused by the solar wind, a continual, intense torrent of charged particles, or plasma, spewing out in all directions from the Sun, colliding with a cocktail of gas, dust, and cosmic rays that sweeps between star systems known as the interstellar medium. Observations using radio and X-ray telescopes have helped scientists piece together a picture of what the interstellar medium is made of throughout the last century. They discovered that it is made up of extremely diffuse ionized hydrogen atoms, dust and cosmic rays intermingled with dense molecular clouds of gas, which are assumed to be the genesis of new stars. However, its precise nature just outside our solar system has remained largely unknown, owing to the fact that the Sun, all 8 planets and a distant disk of debris known as the Kuiper Belt are all housed within a massive protective bubble generated by the solar wind known as the heliosphere. As the Sun and its planets hurtle across the galaxy, this bubble acts as an invisible shield against the interstellar medium, keeping the majority of dangerous cosmic rays and other debris out. However, its life-saving properties make studying what lies outside the bubble more challenging. Even estimating its size and shape from within is challenging. It's like you're inside your home and you want to know what it looks like. You have to go outside and take a look to really tell, says Elena Provornikova, a postdoctoral researcher at the Johns Hopkins University Applied Physics Laboratory. The only way to get an idea is to travel far away from the Sun, look back, and take an image from outside the heliosphere. This is no easy task. Our solar system appears to be the size of a grain of rice floating in the middle of the Pacific when compared to the entire Milky Way. Even so, the outer border of the heliosphere is still so far away that it took the Voyager 1 and Voyager 2 spacecraft more than 40 years to reach it as they raced from Earth. Voyager 1, which took a straighter path through the solar system, entered interstellar space in 2012, followed by Voyager 2 in 2018. They are currently 14 billion and 12 billion miles from Earth respectively, and are presently drifting out into space beyond our solar system, sending back more data as they travel. What these two aging probes discovered about the heliosphere interstellar medium boundary has provided new insights into how our solar system evolved and how life on Earth is even viable. The extreme edge of our solar system, far from being a defined boundary, churns with turbulent magnetic fields, colliding stellar windstorms, storms of high-energy particles, and whirling radiation. The size and form of the heliosphere bubble change as we move through different regions of the interstellar medium and as the Sun's output changes. When the solar wind rises or falls, the outer pressure on the bubble changes. The Sun's activity spiked in 2014, causing what amounted to a solar wind hurricane to sweep out into space. At over 800 miles per second, the blast swept over Mercury and Venus. After 2 days and 150 million kilometers, it enveloped Earth. Fortunately, our planet's magnetic field protected us from harmful radiation. A day later, the gust passed Mars and continued through the asteroid belt towards the distant gas giants Jupiter, Saturn, Uranus, and after more than 2 months, Neptune, which orbits the Sun almost 4.5 billion kilometers away. After more than 6 months, the wind eventually reached the termination shock, a position more than 13 billion kilometers from the Sun. Here, the Sun's magnetic field, which propels the solar wind, weakens to the point where interstellar medium can push against it. The solar wind gust exited through the termination shock at less than half its prior speed, reducing the hurricane to a tropical storm. Then, in late 2015, while still inside our solar system, the solar wind surge approached Voyager 2, which is about the size of a compact car. Voyager's 40-year-old sensing technology, powered by a slowly failing plutonium battery, detected the plasma surge. The probe sent data back to Earth, which took 18 hours to reach us, even at the speed of light. Astronomers could only receive Voyager data thanks to a gigantic array of 70-meter satellite dishes and advanced technology that could not have been envisioned, let alone invented, when the probe left Earth in 1977. After a little more than a year, the dying wind reached Voyager 1, which had entered into interstellar space in 2012. The data revealed that the turbulent boundary is millions of kilometers thick. It covers billions of square kilometers around the surface of the heliosphere, but many questions remained unanswered, including those around exactly how typical our protective solar wind bubble might be. Well, the solar wind was one type of energy the Voyagers caught, but then a group of scientists discovered something unexpected while mapping out the universe: an unknown object emitting bursts of energy every 18 minutes. This mysterious object in space is pulsing in a way astronomers have never seen before. It may be a strange neutron star, the remnant of a massive star that has exploded. Examining celestial objects like it could help us grasp the dying days of stars. When a big star runs out of fuel and collapses, neutron stars arise. The very center of the star, known as the core, collapses, compressing every proton and electron into a neutron. If the core of the collapsing star is between 1 and 3 solar masses, the newly generated neutrons can arrest the collapse, leaving behind a neutron star. Stars with higher masses will continue to collapse into stellar mass black holes. This collapse leaves behind the densest object known, an object with the mass of a sun squished down to the size of a city. These stellar remnants are around 20 kilometers across. On Earth, one sugar cube of a neutron star material would weigh nearly 1 trillion kilograms, roughly the weight of a mountain. Natasha Hurley-Walker of Curtin University in Perth, Australia, and her colleagues discovered this object with the Murchison Wide Field Array, MWA, an Australian radio telescope. After noticing a barrage of radio waves that appeared and then vanished, scientists went through archival data collected by the MWA in early 2018 and discovered 71 further pulses. The object, known as Gleam X and located approximately 4,000 light-years away, discharged massive amounts of energy with each pulse. In a press conference, Hurley-Walker observed, "The brightness here is just crazy, really extreme. We did not expect to find anything so bright." It had a consistent rhythmic pulse, brightening once every 18.18 minutes for 30 to 60 seconds. Nothing like this has ever been discovered. The majority of flashing radio objects in the sky pulse at a much faster rate, brightening and dissipating in a matter of seconds. No one really thought of looking for objects on this timescale because we couldn't think of any mechanisms that produce them, and yet they exist, said Hurley-Walker. Other observations of the object's light suggest that it must have a strong magnetic field, and the pulses suggest that the object is likely spinning. This led the researchers to think it might be a magnetar, a kind of neutron star with an especially potent magnetic field, although it's unclear how a magnetar could rotate so slowly and glow so brightly. I was concerned that it was aliens, but it is across a very wide range of frequencies, and that means it must be a natural process. This is not an artificial signal, said Hurley-Walker. She and her colleagues are now looking for more objects like this so we can figure out what they are. Due to the fact that they are often the remnants of a massive star that has died, astronomers have previously discovered objects in space that periodically switch on and off. These light bursts are referred to as transients, according to co-author and Curtin astrophysicist Gemma Anderson. But what makes this object unusual is that it doesn't behave like a transient. Energy bursts would erupt over the course of a few days in a slow transient before going away for several months at a time. One flash lasting up to a minute would be unusual because fast transients often flash on and off within milliseconds or seconds. Though they do have some educated suggestions, the team is still unsure of what it might be. Hurley Walker speculates that it might be an ultra-long period magnetar, a particular kind of slowly rotating neutron star with a powerful magnetic field. But it was regarded as something that only existed in theory. Nobody expected to directly detect one like this because we didn't expect them to be so bright, Hurley Walker said. Somehow it's converting magnetic energy to radio waves much more effectively than anything we've seen before. The mystery object is similar to a lighthouse, according to Seth Shostak, senior astronomer at the SETI Institute, who was not part in the research. He believes that most astronomers agree with Hurley Walker that it is most likely a dead star. Shostak mentioned that once the Square Kilometre Array telescope is finished, it will be the largest radio telescope ever designed and built. This will allow astronomers to examine space even more, which could lead to the discovery of additional objects similar to this in the future, as well as a more precise understanding of what they are. What do you believe this object is? Is it a dead star or something alien? Tell us in the comments.